In this video, I'm going through a practice exercise on data preparation. On the real exam, it can be bewildering when you first look at the data set. You try to read the data dictionary, and it's overwhelming to try to understand all of the variables and look at the statistics and look at the graphs and then try to interpret them in a way that is easy to explain. So hopefully this exercise will give you some practice in doing that. The data set comes from the UCI Machine Learning Repository, which is a massive open source collection of data sets that machine learning researchers use in order to test different models. This is a bank data set where the variable here, I'll just if you just Google UCI machine learning bank, you will see a description. So I've downloaded the CSV file onto my computer and I've created a R project. I've copied the data dictionary here and I've have some tasks. The first task is to examine the target variable, which in this case is whether or not the client has subscribed to a term deposit, and then decide on which variables to keep or discard, examine the numeric variables, and then examine the factor variables. So the target variable in this case is whether or not the person has subscribed or not. And the predictor variables are um, client data, such as their age, their job, their marital status, education status, related, and the variables related to the last contact or their history with the bank, such as the contact communication type, where they called on the phone or a cell phone, when is the month of the year of their last contact, the day of the week, the duration, and so forth. Other attributes such as their campaign, previous number of contacts performed, as well as social and economic indices such as the quarterly rate indicator, the consumer price index, and so forth. So to start, I'll look at the data with Glimpse, and I can see that there are 42,000 observations and 21 variables. The target here is Y. It's either 0 or 1. I want to look at the I want to look at the number of yeses and the number of nos, and I see that there are about 40,000 nos, only about 4,000 yeses. This is important to note because if you're building a classification model, this is what's called an imbalanced class. And so you have to use certain techniques such as oversampling or undersampling or stratified sampling when you are training the model. To look at the percent, the subscriber percent by a categorical variable, simply group by that category and then summarize and then say percent subscribed is equal to the mean of the cases where Y is equal to yes. You can see that it's 10% on Fridays, 9% on Mondays, 12% on Thursdays, and so forth. And you can also change this to any variable that you want. Like, let's look at education. You can see it's 22% for those who are illiterate, 14% for those who have an unknown education, and for those who have 6 years or 9 years of education, it's much lower. It's about 7 or 8%. Task 2, decide on which variables to discard. Read the data dictionary and, if appropriate, discard any variables that would not be useful for building a predictive model. So uh, basically, this is asking you to read everything in the data dictionary. You may notice the duration field. This is the last contact duration in seconds. An important note, This attribute highly affects the output target. For example, if duration is equal to 0, then the target is equal to no. Yet the duration is not known before a call is performed. Um, so in other words, this is what's called leaking the signal into the data. So if you're building a model and you have some variable that is directly related to this target, to the thing that you are trying to predict, then you cannot use that as a predictor variable because it's cheating. It's peeking at the answer before you even try to fit the model. And what you'll see is if you put that into the model, it will just show up as the most significant variable. It will have the highest variable importance and so forth. But it's not really helping you predict the future because you already know what the result will be ahead of time. So it's like if you are taking a test and you already know what the answer to a question is, you don't even need to look at the question or look at the data at all. You just automatically know the answer. So you can't use that in the model. The other variables I was looking at seem to be okay. I couldn't find anything else that would be uh, a cause for exclusion. So to remove a variable, I would just say bank is equal to bank and then select minus duration. To look at the numeric variables, I use select if is numeric and then run a summary. I can see that age is approximately symmetric but slightly right skewed. And I can look at the histogram and see that there are a lot of values that get cut off right at about 60. So these are probably people who are over the age of 65 who are retired. Maybe they're not eligible for this type of loan. I can look at campaign. Campaign is between 1 and 56, and it is also right skewed. Yes. Um, Now, it looks like there might be some values that are very high. This goes from 1. See, the third quantile accounts for 75% of the records. The third quantile is only 3, but the maximum value is 56. So is this okay? Should this observation be removed? Is this an outlier? The only way that it would be okay to remove this in the context of this exam is if they explicitly tell you what the range of the values should be. If they say that the maximum value should be 5 and you see a value that's 60, then it would be acceptable to remove that value. But if they don't give you a range, then it's impossible to say what is a legal value and what's an illegal value. So in this case, the campaign is just the number of contacts performed during this campaign for the client. So it could be that this is just a unique case. This is just a case that actually had 60 contacts. And so excluding it would be um, missing information. It would be removing useful information from the data. So P days has a lot of 999 values. You can see there are values from 0 to 1 to 2 to 3 to 4 consecutively up to 27, and then there are 40,999 values. And if you look at the data dictionary, you'll see that P days is the number of days that passed by after the client was last contacted from a previous campaign. So 999 means that the client was not previously contacted. Um, so you could say that this is not a real number. this is actually an NA value. It's a missing value. Because they were never contacted, you don't have data for them. You don't know when their last campaign was, right? So the modules don't cover missing value analysis or missing analysis, but there's a lot of theory around missing values. Um, there's something called missing at random or missing not at random. Basically, missing at random is when there's absolutely no pattern in the missing values. Let's say you're in a laboratory, you're conducting an experiment, and someone knocks over a a bunch of vials, and you lose a bunch of your samples, and it just randomly happens, and there's no pattern, and so some of your data is missing. That's missing at random. Missing not at random is when there's something causing the values not to be missing. So in P days, maybe they're not missing. Maybe we don't have prior contacts because these people don't want to take out a loan, or there's some legal reason why they are ineligible. In that case, this is um, not missing at random, and there's some pattern. So if you just remove the values from the data, you are, removing useful information. So you don't want to do that. So there are at least two ways you could deal with this. You could create a flag, which is 1 when p days is equal to 999 and 0 otherwise, and then just use this as a separate variable. You could also create a new factor, which would be a bin. So it would have all the values from 1 to 10, and then from 11 to 20, and then 20 to 30, 30 to 40, and so forth. And then it would have a separate category for none, which would be 999. Then you could include this. If you use either of these values, you'd want to remove the original pdays value variable so that you don't have a linear dependency in the model. For the next variable, previous, let's look at the summary. This is a numeric value. You can see that the median is 0. And it looks like it has discrete values. There are 40,000 zeros. It goes up to 7. So you could include this as a numeric value, just as is. Um, if the variable is skewed and you're using a linear model, you should apply a log transform to correct the skewness. If you're using a tree-based model, a decision tree, random forest, or GBM, you don't need to apply log transforms to continuous variables. But if you're using a lasso, a ridge regression, or a GLM, then you should. So if you look at like age, this one's approximately symmetric. So you might not need to apply a log transform here. You should definitely apply a log transform to campaign because this is highly skewed. Previous is a counting variable, so it's not necessary to apply a log transform. Then there are these economic indicators. There's employee rate, consumer price index, and so forth. If you look at the summary, you can see that they're numeric values, and you look at the counts, you can see that there are only 10 unique values. If you look at the data dictionary, you can understand why. Employee veramate is the employment variation rate quarterly indicator. So it's only updated every quarter, every 3 months. And so that means that it doesn't have very many unique values because it's only at the quarterly level. The same with the consumer price index; it's at the monthly level. So it doesn't
Okay.
vary um, by record. It varies by the month that the record was collected, which is okay. It just means that it will not have as much information as it will not vary at the individual level. So if you look at it, you can see that it goes from like -3 up to 1.4. I don't know what the units of this are. If I did, I might apply some transformation. If I had some insight into what an employment variation rate was, I might engineer some new features. I might simplify this down into just a
Positive.
positive or negative value. It will be 1 if this rate is positive. It will be 0 if this rate is negative. If you don't have a lot of domain knowledge about the data, it's difficult to
Okay.
engineer these types of features. Um, Let's look at the consumer price index. Okay, you can see it's this looks like it's more continuous. Um, that there's still
Still
a
a
lot
lot
of
of variance.
variation. So maybe a good strategy here would just be to create bins, from 93 to 94, 94 to 95, or just round the value down uh, and use that instead of the raw value explicitly. Um, it's the same story with these other economic variables. Next is to examine the factor variables. Um, Now, you can do things like look at the box
But
plots, like here. This shows you on the x-axis the frequency or the number of records in each of the categories. So most people have a job that is an administrator. The second
second,
most common job is the blue collar job, or about 8,000
1,000.
people who have a blue collar job. And there are about 7,000 who have a technician job. And the colors represent the rate. Um, so you can see in all
Okay.
cases, most people are not subscribers. It's not
Not
really
really.
clear just from looking at these bars um, what
What
the
the
rate is. It looks like it
second
might
might
be
be
a
a
little
little.
bit lower for blue collar jobs, and the rate might be a little bit higher for admin. It might be higher for technician, but it's hard to see just from the graph. That's why it's nice to be able to look at the tables as well. So if I group by job and then look at the percent subscribed and then round to 2 decimal places. And then I want to arrange by descending. I can see, students actually 31%. Retired is 25%. Something was wrong with this bar graph because, oh, well, no, I revised what I said. This is ordered not by the rate. These are ordered by the number of total records. This graph is ordered by the rate. This is more useful for the problem because you can see students have the highest percent subscribed, uh, and students and retired people. So maybe these are students who are taking out loans to pay for school, or these are retired people who no longer have a normal income. Uh, and in fact, if you look, students don't have a normal income, retired
Tired
people
people.
don't have normal income, and unemployed people don't have a normal uh, salaried income. So that you can see right there, there's um, more information that you can gather by looking at the table rather than looking at this bar graph. And so, um, if you want to change this to the other factor variables, um, you can just do so. So here I'm selecting. Well, first I'm mutating if the variable is a character, converting it to a factor, and then selecting those that are factors, and then looking at a summary. And this shows you the number of records by each category. So most jobs are admin. You can see 10,000 records. Most people are married. There are 25,000 married people. The most common education is a university degree, 13,000 records. The most common default level is no. Most people have not defaulted on a loan, 33,000, and so forth. And then if you want to look at the rate by each of these levels, just change the group by. So 15% of those with an unknown married status has subscribed versus 10% who are married. So when you're married, you're less likely to need to apply for this type of loan. Finally,
Finally,
a common question that comes up is, how
how
can
can
you
you
tell
tell
if
if
a
it's
variable is predictive? And if a variable has the same average
average?
response across each of its levels, does that mean that it is not predictive, that it shouldn't be used in the model? Like, let's say that you were looking at, day of week, right? And you can see that it's about 10% for all days of the week. There's some variation at the second
Second
decimal place, right? But
But
it's
it's big.
basically constant. Does this mean that day of week is not a predictive variable and then we can just drop it from the analysis? Well,
Well,
let
let
me
me.
ask this question. What
What if
if you don't just look at the day of week, but you also
also
look at the education level? You can see there's a
a
lot
lot
of
of
variation here. For those who are illiterate on Wednesdays, it's 50%. Um, and for those who are illiterate on Thursdays who are contacted, it's 33%, right? And so there's a lot of variation here, or maybe not day of the week. Maybe you want to look at, I don't know, month, and you can see that there's maybe some type of seasonal pattern. So if you just
just
look
look at
at one level, just day of week, it looks like there's no pattern. But when you include other
other variables.
variables, there might be a pattern. And you can the you can't just look at even two levels. Even that's a simplification. If you go to model,
Model
it's
is that
actually going down and looking at all
all
of
of
these
these
levels at once. It's looking at job and education and contact method. Was this person a student who had a 4-year education who was contacted by cell phone? What
what
is
is
their
there
subscription rate? Was this person a technician who had a 4-year degree who was contacted via cell
cell
phone?
phone
Right. So the
punchline
punchline is that with only looking at one
one
or
or
even two
levels.
levels, there's not enough information to say what will be predictive. The entire purpose of fitting a model
Model
is that it can account for multiple variables at once. You can use models for data exploration, like a common
common
use
use
of
of
decision for random
forest.
forests is just to get variable importance. right? Just to reduce the variables and then figure out which are most predictive. Or if you're using a lasso, you can quickly remove variables which are not predictive. Subset selection is a little bit less clear. It's still useful, but it takes a little bit longer and it's um, a little bit more arbitrary. But it's still another way of reducing the number of variables. Or if you're using even a decision tree, you can change the parameters in order to make the tree smaller and thus force the model to use the most predictive variables. If you're just using a GLM by itself, it doesn't perform variable selection, then you need to select those variables yourself.